All right, welcome to Lecture 9, Part 3, Predicting Ionic Formulae. Formulae, doesn't matter. All right, this is fairly easy. It's based entirely on the charges of the two species involved. So, for example, what are you going to get when you mix potassium and chlorine? Well, we come to our periodic table, and we find potassium is over here in the first column, so it's going to take a 1 plus charge. Chlorine is over here. It's a halogen. It's going to take a 1 minus charge. 1 plus and 1 minus. So, in order to find the formula, you cross the streams. And you just bring the charges down, and they become numbers. Okay? So, K1, Cl1. Except that for subscripts, we never bother writing 1, so it's just K. Similarly, let's look at magnesium. And let's go with nitrogen. Jump over to the periodic table. And we have magnesium here in the second column. It's going to take a 2 plus charge. And here's nitrogen, head of the nitrogens. 1, 2, 3. It's going to take a 3 minus charge. 2 plus, 3 minus. And you cross the streams. That's going to get you Mg3 in 2. Now, the reason we're doing this is that there's a shortcut hidden in here. What we're doing is we're balancing out the charges. Okay, you absolutely, positively have to keep the charges balanced in the whole thing. And this gets you a balanced charge because 3 times 2 plus is 6 plus. Oops, not 6x, 6 plus, and 2 times 3 minus is 6 minus. So the two charges balance each other out. So that's why we're doing this. This just sort of shortcuts it and hides the math necessary to do that. But I want to give you another example real quick. Let's go with beryllium and oxygen. We hop back over to the periodic table. Here's beryllium. It's at the top of the alkaline earth metals. It's going to give it a positive 2 charge. Oxygen is Mr. Chalcogen. 1, 2. Oxygen takes a minus 2 charge. 2 plus, 2 minus. We cross the streams. And that gets us Be2O2. And on a test, that would be wrong. Because, you have to reduce this right here. Okay, so Be2O2 is incorrect. You have to reduce it. Okay, these are both divisible by 2. So it becomes BeO. Okay, it's just a 1-to-1 ratio. Because 1 times 2 plus is 2 plus. 1 times 2 minus is 2 minus. You don't need 2 of each, you only need 1 of each. Okay, we're showing the reduced ratio. Okay, it's like instead of 2/4, you write 1/2. Okay, you always reduce the ratio as much as possible. So look for common factors. You can also get ions using the multivalent metals. So, for example, iron and oxygen. Now, you won't be able to predict just from knowing that iron is involved what the formula will be, because you can get iron 2 plus and iron 3 plus. So I will always have to indicate for a multivalent metal what the charge is, because you can't predict that just by knowing what the metal is. But if it's an alkali or an alkaline earth, or silver, zinc, or aluminum, then you can predict the formula because you know the charges on those bad boys. You can also do this in reverse, but I'm going to hold off on that until we've discussed chemical nomenclature. That is to say, the next lecture.